Good morning. Welcome to a talk I've been asked to give called What's Hot in Technology? That's actually a very difficult question. In signage, there's not a lot of new technology around, and I'll explain why. But we'll start by winning a bet in my office. They claimed that I'd never dare to do this, but we want hot technology, there's hot technology. Thank you very much. I'm Bryan Crotaz. I'll see you next year. You've got more. So signage is not exciting technology. You're not going to see a new technology out every 2 years. I've been doing this nearly 20 years now. And we still have screens. They're a bit bigger, they're thinner, they're brighter, they're cheaper. The speakers are more efficient, they're more directional. But essentially, we've got pictures on a wall, and we've got sound coming out of the speaker. The technology is not doing new things. We're seeing augmented reality, we're seeing virtual reality. They're not practical in any sense. You'd never go and roll them out into your 5,000 retail locations. It's not the technology that's important, it's what you do with it. And it's the content, and it's how you put it together that makes the difference. So real-world projects need displays. They need monitoring to check that it's still working. They need sensors to tell you whether anyone's actually watching your screens, whether anyone's actually consuming your signage. They might need sensors to determine the length of the queue, or how many people are walking into the environment. You might want to change your content based on those sensors. And the problem with sensors and systems is they all talk different languages. So we have signage, we have event management, we have room booking systems. We might want to bring all that data together. If we're working in a conference arena, the signage will change according to what's in the theatre right now. It will change according to who's booked the stand next door. If you're working in a corporate environment, it might be based on who's holding a meeting this afternoon. And then we have the sensors on the right-hand side bringing live data into that system. We want to drive displays, monitoring, alarms from those sensors. But all those sensors are made by different manufacturers, they speak different languages, they use different technologies. And it's very difficult, historically, to bring that together into one system. If you can bring it into one system, then you can provide something really spectacular for your client, using digital signage and other technologies as a tool, rather than as a finished product. So to do that, we can use the Internet of Things. This is something that's really come to the fore in the last 18 months, 2 years. There's been some agreement across the manufacturers about how we can talk to an Internet of Things and bring devices together into a seamless, cohesive system. So we have all sorts of disparate technologies in the Internet of Things. We have serial ports, we have Bluetooth, we have more low-end technology like CAN bus, which is used in a lot of audio products, a lot of car systems. Zigbee is a radio product for very low power, battery-operated equipment. We've got our standard TCP, UDP network data, Wi-Fi. We can even connect up devices that impersonate a USB keyboard, so they're very easy to communicate with PCs. And somehow we have to make all these different devices talk to each other, even though none of them can even hear each other shouting, let alone speak the language. So to do that with Internet of Things, we can treat all of the information coming from those devices as messages. It's a piece of text. We don't care whether that text came over Zigbee or Bluetooth or CAN bus or Wi-Fi. It doesn't matter. It arrived into a queue. What we can then have is subscribers that say they're interested in a particular type of message. So I might only be interested in messages related to my room. I might only be interested in lighting messages or digital signage messages. And the queue will deal with passing those messages out to anyone that's interested. And that's the whole basis of the Internet of Things. So the idea of IoT is that it simplifies something that was incredibly complicated. We have sensors and data such as your calendar or your room booking system, coming into a set of rules via that queue. And then from those rules, we can go out to displays, we can show, we can bring in control systems, so buttons that control. We can go out to IT dashboards to check that everything's still turned on and working. And we can drive real-world actuators, move things in real life. That might be locking a door, unlocking a door, moving a turnstile, moving some lighting. And we can bring in alarms in, so if anything goes wrong, we can inform people by email, text, or whatever we want to do. So take a simple example, a light switch controlling a light bulb. If it was that simple, we just run a power cable between the two, switch the light switch on, the light comes on. Very simple. But if we then want a master switch that can turn off all the lights on the floor, or we want a motion sensor that can make the light only turn on when there's someone in the room, and if you leave the light switch on, the light will go off by itself. And if you then say there's a light in the corridor that only turns on if some of the rooms are occupied, then you get something where the rules get to be quite complicated. And this is the sort of complexity where the Internet of Things becomes useful. So what do you need to consider when you're looking at an IoT installation? Well, the biggest problem is that devices disconnect. You're going to be tending to work with devices that are battery powered. If you've got a battery powered device, if it has its radio turned on the whole time, that battery's going to last 3 or 4 hours. But a Zigbee device, to be certified, has to last 5 years on one battery. So what they do is they only turn the radio on for maybe 3 or 4 seconds, every 5 minutes, every hour, and they synchronize between themselves, so they all come on for the same 5 seconds, chat to each other, get back again. If one of them has a message like a light switch turning on, you obviously want that message to go immediately, and those can be sent instantly. But if they are sending log messages or just listening for what's going on, they'll connect a lot less frequently. So it's completely normal for most of your devices to not be talking to your server most of the time. You also obviously need to consider data security. You're sending out what is potentially secure data out onto your network and potentially out onto a wide area network. That might be data related to who's in the building. It might be data related to there's no one in the building. You can come and burgle us right now because there's no one here. It might be data related to where the security guard is on his travels. So your burglar can follow him around, just going into the room after he goes in there and taking everything out. So it's really key to get your data encrypted and to look at which encryption technologies are the right ones to use in your environment. Because every time you encrypt something, you make it harder to use. So you have to get a balance between usability and encryption quality. You also need to consider authentication. My light switch has to authenticate itself as one of our light switches, and not next door's light switch, or my attacker's light switch. Wouldn't it be great if I could walk up to a building and turn all the lights off? If my light switches don't authenticate onto the system, then any attacker can come in and impersonate a light switch and turn all the lights on. And obviously in a real world environment you could do something much worse than that. So we're, for example, building a scoreboard for a stadium in January next year, and the scores will be sent over IoT technology. So as a member of the audience, if I didn't authenticate the scoring system, I can sit there with my mobile phone and put my own scores up on the board, and no one will be able to control it. So the combination of data security, encryption, and authentication is very important. You also need to consider resilience. So if, for example, my light switch talks to my light bulb via the cloud server, and my internet connection goes down, I can't turn the lights on. So you need to think about what might go wrong in your physical environment, and where those paths are critical and where they're not critical. If they're not critical, absolutely fine to go via the cloud. But if they're critical, you need to be thinking about IoT technologies that are on-premise, point-to-point, within the same network, probably without radio. So a typical large system, you would have a sensor talking to a gateway device. Intel, Cisco, various others make very secure IoT gateway devices that are sub $100 that will have various radio interfaces. They might have Wi-Fi and Zigbee and CAN bus on them, for example. And the job of that gateway is to pass messages around. So all the sensors will talk to the gateway, and the gateway will deal with where that data needs to go. So, for example, I might have the sensor being a light switch, and the locally controlled device being a light bulb, and they will talk directly via that gateway, probably over a LAN connection on a wire. But equally, I might want to send data up to the cloud. That might be monitoring data, it might be my building management department wanting to know how many hours of those light bulbs beyond, when do we need to replace them. So for that, I'll have some rules in the cloud, and I might pass that back to a device back in my office. Now that device on my office isn't connected right now. So if I want to push data to it, I can't. So what you do is you put a virtual device in the cloud that maps to that real world device. You push the data to the virtual device. And then when the device connects, it will pull down the latest data from the virtual device. So the virtual and the real device are mirrors of each other. but the real-world device only connects every so often and pulls its data down. So that path gives you the ability to do resilient local control, plus cloud control, and obviously you can bring in external data through your cloud as well. It also allows you to do the disconnected devices. What you would then do is you would authenticate your sensors and make sure they have permission to connect, and you would encrypt your data when it goes out of your building. You're probably okay passing it around your building without encryption. You can be reasonably certain that attackers aren't in the building. So you can use Internet of Things to ask questions of the world. When's my next train? Bring some external data in. Which platform does it park on? Bring some different data in. Is the lift working right now? Those are the sort of questions we can start to ask. When is my next train? We've been able to do that for a long time. But we couldn't ask, is the lift working? How long will it take to get there? Now those sort of things are quite simple. They have some value. But what if we say, do I have time for a coffee before taking a taxi to the station? Can we ask that question and get a meaningful answer? Well, we can. There's a database that says when the train leaves. The kiosk you're talking to right now tells me where you are, or your mobile phone might tell me where you are. We've got routing software, and internal mapping, external mapping, that gives us the walking time to get to the taxi rank. We can get the walking time if you go via the coffee shop. We can then look at the queue length in the coffee shop in minutes, and say how long it will take you to get your coffee. And we know the lift is broken, so we know to add some time for going up the stairs. So Internet of Things can take the data systems that we've already got and bring them together with the devices and the sensors of the real world and allow us to ask much more complicated questions of the real world, which allow us to give much more fully featured systems to our clients. I think I'm slightly short of time, so I'm also going to show you a video as a taster of what's coming. This is not Internet of Things, but it is particularly spectacular. You've probably heard of Magic Leap. It's a company sponsored by Google. It's got something like $1 billion of funding. And the aim is that it is the next wave of video. And I just lost it down there. I wasn't planning this, so I assumed I was going to overrun. So if you're sitting here, there we go. So what Magic Leap is doing is a little bit like Google Glass. It's a device that you wear on your head. So you wear it on your head, and it can bring you a virtual reality environment. Now Google Glass was a little picture that you had to focus on in the corner of your vision. It's a flat plate. I don't need all the other slide. A flat plate that you had to focus on. What Magic Leap are doing is projecting light rays onto your retina, but from all directions. So the light feels as if it came from over there. That means you don't need to focus specially on it. You can focus in the distance and you'll see the thing that they're throwing in. It's also got depth sensors built in, so it knows where all the objects in the room are. So it can send the virtual object behind something in the real world. Now, they've been talking about this for about 2 years. Last week they released their first demo, which they claim is shot through their device. I'll leave you to make your own mind up as to whether this is real or not, but if it is, this is going to change the world in 2 or 3 years' time. So you can see there that it's obscured by the desk, it's detecting where the desk is, and cutting it out, and as the leg goes in front of the object, you can see it's obscured. This one is particularly interesting. They're actually focusing through the scene. So you can see that the rendered scene goes out of focus. And you'll see there's a glow on the table from the sun that they're rendering into that scene. So they're detecting the positions of all the objects in the real scene and throwing the virtual environment onto that. Now, if we talk about what's hot in technology in 2, 3, 4 years' time when this gets released, this is going to really change the world. They're talking about having games where you can volunteer, if you're a fantasy fan, you can volunteer to have orcs attack your office every so often, randomly. And they'll come up from behind the cubicle and run around the door, and you have to fight them off. But they won't tell you when they're coming.